Hey, good morning, good afternoon, everyone, and thanks for joining the AWS Malta user group session on data lake on AWS. I welcome everyone, and thanks for joining with us. And we have our guest speaker. I welcome Mr. Aditya. Thanks for joining with us. So here we have Aditya. Hey, Aditya, thanks for joining with us.
Hey, it's my pleasure. How are you?
I'm good. Thanks, and it's really honor to have you here because when we asked and you're agreed with us to have the session on data lake, and this is one of the great session we believe because it's really helpful for us in terms of understanding more in terms of technology and automating in terms of solutions in data lake, etc. So I would like to have my introductory presentation with us. Let's keep eye on
Okay.
us. Okay, here. Okay, so this is our first session on data lake on AWS with Aditya, and this would be a session on introductory and intermediate session. And I welcome everyone again. I welcome everyone who are joining all over the world, in Europe, Malta, and other countries all over the world. Thanks for joining with us. So here we have the agenda. So I welcome Aditya Challa. So I would like to introduce him. And about Aditya Challa, he is 16 years of experience in software professional with expertise in areas of solution architecture, product design and development, implementation, migration, application maintenance. Over 8 years of experience in financial services and payment industries, known for providing end-to-end reusable service-oriented architecture solutions to business problems, defining, designing technology blueprints, and driving innovative solutions to realize tangible value to stakeholders and business partners. His hands-on experience in trending concepts such as cloud computing, microservices, serverless architecture, RESTful web API, OAuth 2, event-driven process automation, big data processing, NoSQL databases, single page applications, mobile applications, etc. So again, thanks, Mr. Aditya. Over to you.
Do- Are you able to hear me?
Yeah.
Awesome. All right. So thank you for that nice introduction. Hello, team. Very nice to meet you. Let me quickly share my screen. Can you see my slide deck here? Hello. Ganesh, are you able to see my slide deck?
Yes, Aditya, I can see your slide deck.
Okay, great. So good morning, good evening, good afternoon, team, wherever you are. Very nice meeting you. I know Ganesh did a great introduction, but I would like to add a couple of things just from my side. So my name is Aditya Challa. You can call me Addy. I am an AWS Senior Solutions Architect. I've been with AWS for about 3.5 years now, and been in the IT industry for about 16 years and working with cloud technologies since 2012 or so. I actually am really passionate about AWS Cloud, and I have all currently available AWS certifications. In fact, I recently renewed a big part of them. Like I started in 2018, and then they expired recently, and I had to renew them. So really passionate about cloud, really passionate about AWS Cloud. And today we're here to talk about data lake on AWS. So you probably are familiar with the term data lake or data warehouses, or using technologies like Oracle or maybe you probably have heard of the term Redshift. So all that falls under data warehouses and data lakes. So that's really what we are here to talk about. And let me get quickly started. Oh, by the way, as far as location is concerned, I'm in Arizona, which is in the United States, so close to the West Coast. It's about 5:35 a.m. here, so pretty really looking forward to this session. Okay, so as far as realities, there are some new realities out there that our customers are facing. One, there is an explosion of data. So I know 5 or 6 years ago we heard of the term big data, that talks about high velocity, volume, and high variability. But the explosion of data that you see today is exponentially higher than what we saw when big data was trending 5 or 6 years ago. So, and then the amount of people who are using this data is also exploding, like personas, and the demand for faster decision making or real time data is also increasing, which means it's no longer just, okay, give me the data and I will wait till the next day or next week for the process to be over, and I'll give you some results. No, whatever data we are getting, we need to be able to provide results right away as soon as possible. So there is more data than people think. So we've seen data growing at the rate of 10 times every 5 years, which means if we are getting started now, if we are building something now, we need to be able to support that at least. And if we need to be able to support that for the next 15 years, we need to start something that can scale up to 1,000 times. Because if data grows 5 times every or 10 times every 5 years, and then we have 15 years, then that's like 10 to the power of 3, which is 1,000. And then the amount of people, or the type of people, or the variety of people that's accessing this data is also growing. Whether it's data scientists who want to run their machine learning models on the data, or business users who are just trying to get a dashboard, or analysts who are trying to make sense of some data that they're seeing, or applications that run queries on this data. There are various personas that are trying to access this data, and we need to be able to do that, or they need to be able to do it in a secure fashion, real time, in a flexible fashion, which means they should be able to get whatever they need without having to make a lot of heavy lifting, and then in a scalable fashion, of course. So there could be a few megabytes that an analyst want, or there could be a few terabytes that an analyst want. So regardless of the requirement, we should be able to support all of it, right? And so how do we really do this? Like, how do we make sure that more and more people are able to work with more and more data, but at the same time, enforce governance and controls when it comes to compliance or policies that we need to enforce? How do we make sure we democratize this data, where we don't really, our users don't have to go through a lot of red tape to get to the data that they need, versus how do we also keep the balance of making sure that they're not get accessing data that they're not supposed to, or doing something with the data they're not supposed to. So for that, the solution that the industry has come up with is a data lake. A data lake is a centralized repository that allows you to store all your structured and unstructured data at any scale. So it's basically, it doesn't really matter what kind of structure the data has, whether it even has any structure, or maybe it has some structure. Just take the data, ingest it in one place at any scale. It shouldn't have any kind of limitations when it comes to the amount of data that's being stored, or the speed at which it's coming in. store it in one place, and make it available for future systems that need this data, or systems that are going to process the data or consume the data. So to get into a little more detail, back in the day, we used to have data silos. So different departments, different teams within an organization would either have their own data warehouse, or maybe if they started recently, maybe they would have a Hadoop environment or ecosystem, as they call it, which is also siloed. So maybe one team is bringing data from their OLTP databases or ERP databases and then putting it into a data warehouse. Or another team maybe is getting click streams or sensor data and putting it all in a Hadoop cluster. And then there's business intelligence coming out of it. But what if there needs to be some data exchange between them, or the user who needs the data, maybe half of the data is in one silo and half of the data is in another silo, or maybe the user is not even aware of some of the silos. So taking all this into consideration, instead of having these silos of data or silos of databases or data warehouses or data lakes or Hadoop ecosystems, the idea is to move to a data lake architecture where, regardless of who is generating the data or what is generating the data, at what speed it's being generated, or what kind of data, um, we bring it all into one central repository called a data lake. And then, regardless of who the consumer is, so whether it is a data warehouse that needs to take some of the data, or whether it is the data science team who wants to run some machine learning models, or whether it's a BI team that's building some dashboards for leadership, all of them can come to this centralized place because all the data is in open formats that can be understood by multiple systems, and it has one centralized catalog, which means, like I said, a few minutes ago, if a user has a use case where half of the data is in one silo and half of the data is in another silo, that would be a challenge. If we had one centralized place, with one centralized catalog, the user can simply use data from both or multiple places or multiple sources that's all in the one same place, uh, to bring all that data in together and maybe make use of that. Okay, so what is the concept, right? So all data in one place, single source of truth. It should be able to handle structured data as well as semi-structured data, unstructured data, or raw data. So let me talk a little bit about what these different or what are the various examples. So structured data is something that has a rigid structure, set number of columns, like maybe a relational database that you exported into your data lake, or a CSV file that has a set list of fields or columns. Semi-structured data is like JSON or XML, where maybe 80% of the records have fixed columns or the same columns, but maybe there's some variability where a few records have extra fields or less fields, right? Or maybe there's some nested data in there. So it has some structure, but we just don't know what that structure is, or maybe the structure might vary from time to time. And then unstructured data is basically like text files or log files, which we really don't know what kind of structure it has. And then maybe raw data could also mean audio and video, and strictly raw data. That maybe it log files. Maybe log files have some structure, right? Maybe it's like text files, but we know what to expect. With raw, we don't even know that. So we bring all that data in to the data lake, and if we are building this data lake, we want to make sure we handle all of this. Otherwise we might run into a roadblock where a team generates unstructured data, and now we don't know where to put it. Okay, Now, fast ingestion and consumption. We talked about it. The speed at which data is being generated and the speed at which the data is being consumed is only growing. So we need to make sure that we can build a system that can support that, at least, especially in the next 15 years, if we are looking to grow, right? Schema on read, what that really means is data is coming in. We don't really have time to, make modifications to our table structure or data warehouse. For example, if we were in the past, if we were ingesting it first into the data warehouse, we had to know exactly what the schema was. So we had to know the schema on at the time of write. But now we're basically saying, nope, we don't care what the schema is. We're going to first dump it and then worry about the schema at the time of reading it. That's really what schema on read means. Designed for low cost storage, decouples storage and compute. So what this really is so if you have more and more data coming in, maybe you'll start small where you only have a few gigabytes of data. So maybe one machine is enough with enough processing power and all that. So back in the day, if we were just starting with a data warehouse, our compute and storage were tightly coupled. So if as data grew up or as more and more data came in, uh, our processor also had to be scaled up because we needed something, a machine that was capable of handling that much data. But that basically meant if we were not really processing the data, if we're not really doing anything with the data, or the data is just sitting there, the processor and the CPU power is just sitting idle. You're paying for CPU cycles that you're not really using. And at some point, it's going to hit a ceiling. And so we can't really scale up beyond that point. So if we are able to decouple storage and compute and just worry about storage and then bring compute power in as and when you need to process the data, and then once the process is over, you can deprovision the CPUs or deprovision the compute power. You are only paying for the storage, and you're also growing with the storage without having to worry about hitting the ceiling for processing power. Of course, we want to make sure we support protection and any security rules to make sure that the governance and control is always there. Okay. Now, with that understanding, I would like to quickly compare what a data lake is, or how a data lake looks when compared to an enterprise data warehouse. A lot of folks believe that if a company builds a data lake, they're all going to stop using a data warehouse, or it's a replacement, or we might lose jobs and things like that. That's not really true. They both go hand in hand, which means a data lake is actually complementary to a data warehouse. It's not a replacement. So you might still need and you might still want to have a data warehouse. The only thing is, instead of the source of that data warehouse being the original sources directly, you might have a data lake as your source, which means first the data is going into the data lake and then going into the data warehouse. A data lake is schema on read, which we just talked about, whereas a data warehouse is schema on write. We had to know ahead of time what the schema was. Structured, semi-structured, unstructured data with data lake versus structured data only with data warehouse. Fast ingestion with data lake versus time consuming, because when the schema changes, you had to first understand that schema, and you have to first understand the schema and then make changes to your data warehouse to accommodate that schema. So there's always some kind of time that was needed to ingest new data into your data warehouse. Data lakes can be used for data science and prediction and advanced analytics and BI use cases, whereas data warehouses are strictly for BI use cases. You can use data warehouses for some data science, but not much. They were really meant to handle BI use cases, provide dashboards, things like that. you can actually get to a very low level of detail or granularity when you have all this raw data in a data lake. Whereas, when you're writing something to a data warehouse, you're most probably doing some kind of ETL before even writing it there. So you're probably, summarizing it or aggregating it. So chances are you lose that granularity once the data is in the data warehouse. Loosely defined SLAs, that's probably one place where a data warehouse is um, shines much better than data lake, because with a data lake you don't really know what kind of schema it is, or where to look for the data. So you give some SLAs, but they're kind of loosely defined. Maybe you basically say, yeah, I can meet that SLA for this kind of data, but I can't really provide you that SLA for a different kind of data or different source of data. With data warehouse, it's like a regular database where you can basically say, here I'm going to follow these tight SLAs at kind of production schedule. So that's probably one thing where a data warehouse will always shine. If there's applications that your users are using and that application needs to hit the data warehouse to um, get data in a production SLA way, data warehouse is probably very useful in that scenario. Flexibility in tools, there's a lot of open source tools and advanced analytics tools out there that can process data in your data lake, whereas with your data warehouse, it's kind of limited because SQL is your only option there. And we talked about decoupling storage and compute when it comes to data lakes. But then when you have a data warehouse, you have pretty tightly coupled compute and storage, which means they're both going to scale linearly. So as more and more data comes in, chances are you're not only scaling up your storage, but also scaling up your compute. Okay. Before I go to the next slide, Ganesh, I'm not sure. I can't see the chat window. Are there any questions so far? Okay, take that as a no. Okay, so how do we cost effectively scale with a data lake, right? So we have all these sources, as you see in the bottom. There's various services that AWS has that can bring data in. So it could be a snowball, which is like, a device that you can request for that comes to your on-premises, and then you copy data to that device, and then the device is shipped back to AWS. Or Snowmobile, kind of similar, but it's just much bigger. It's kind of like a truck. Or you're streaming data through Kinesis or Kinesis data firehose or data streams. Regardless of how the data is coming in, we need to be able to cost effectively scale, which means we might just start with a few gigs in the beginning, but we want to make sure that it can exponentially scale without hitting any limits in the future. So while while we are able to do that, so we are able to take as much data as it's coming in, but we also want stages, which means data probably when it comes in is in a raw format, right? So you might have a landing dock where you first temporarily stage the data, and then you might have some processes like um, some kind of ETL or transforming logic that you code to take that raw data, or maybe take data from multiple data sets or multiple sources, and then create a second data set or another data set that probably will be fed into a data warehouse, or maybe fed into your BI system, or maybe data science team. Regardless of what it is, you probably will need a way to take the raw data, stage it somewhere, and then transform it into another production ready or consumable format. So for that, we recommend that, when you build your data lake, you always divide it into zones. So first we have the raw zone or bronze zone where all the data comes in. And then second, you might want to have a silver zone or uh, an experimental analysis zone or something. So it's kind of like in the middle where you make some modifications, but you're still playing with the data, you're still exploring the data. And then finally a gold zone, which is where 80% of your consumers will be coming to get what they need. So that data is completely curated, production ready, maybe converted to a proper structure that can go into a data warehouse, all that. So it's always good to have zones within your data lake. And regardless of how many times the data is being consumed, we always want to just load, transform, and catalog it once. We don't want to keep doing this again and again for different teams. So we want to make sure that we take all these use cases and do it in such a fashion that once we do it one time, teams are able to consume it the way they want. Now, of course, if you have a different format, then yes, maybe you need another process for that particular team. But even then, we only want to do it once. We don't want to keep repeating this. So we want to be able to implement something that can write once, load once, and then be done with it. And of course, we want to make this data available to multiple tools and support open formats and interfaces. So Amazon has a service called Amazon S3. I'm assuming most of you are aware of it. It's a storage layer, and that's really what we recommend to use for our data lake or for your data lake. And I'll talk a little bit more about it. If you see about who are the consumers, if we talk about who are the consumers, you can see the list of services on the top: Amazon Redshift, Amazon QuickSight, EMR, Athena. We'll talk about some of these services, but basically Redshift is a data warehouse. QuickSight is a visualization tool. EMR is kind of like your Hadoop ecosystem that's completely managed by Amazon. Athena is your in-place serverless querying service, so that you can actually send SQL queries to Amazon S3 directly without having to, have a data warehouse or anything. And then Kinesis is your streaming service. Elasticsearch is Amazon managed Elasticsearch service and other AI services. So regardless of who the consumer is, they can all come to this one place on Amazon S3, which is your data lake. So from perspective of architecture, we want to make sure the systems are decoupled, which means if you have a pipeline where the data is coming in, you first store it, then process it once, again store it, and then analyze it, and finally give some answers. We want to make sure these individual stages can scale individually or independently. Back in the day, this whole pipeline was in one virtual machine or one computer. And so if the process part required a lot more or 10 times more compute power, then you had to scale the whole thing up, and all the rest of the stages were dependent on that process power or process part. Now, if you independently decouple these and say, no, I'm going to have different systems do different things, then you can individually scale process. So if process needs 10 times the compute power, you just give 10 times the compute power just to the process, and then leave everything else the way it is. And so now, if the process power is taking longer to process, then the other parts of the process can still go ahead and maybe process some other data without having to wait for the process part to finish up. Using the right tool for the right job, it's kind of like very important. We don't want to use a Swiss knife where a pocket screwdriver can do the job. Which means, so if you have the right, based on the data structure and the latency, throughput, and access patterns, pick what the right tool is. Maybe SQL is the right tool. You don't have to always use something very complicated like Spark or something to always read a simple set of data which can be simply read using Athena or SQL. At the same time, if the data is complicated, where you do need something like Spark or Glue to put together or do some ETL, then maybe it makes sense. So using right tool for the right job is very important, and we are going to use that in our architecture principles. Leveraging managed and serverless services. So these are services that are managed for you by AWS. So there's always, if when it comes to scale, elasticity, being available, reliable, it's much better if you focus on your use case and let somebody else take care of the heavy lifting. And that's what managed and serverless services mean from an AWS perspective. Using event journal design patterns. So we talked about this briefly, where you write to a data lake and you don't delete or you don't erase it. You write it in an immutable fashion. So if there's need to modify that data, chances are you're going to write another data set that that takes this original data set and then has modifications or new fields or calculated fields, materialized views and stuff like that. Being cost conscious, very important. And finally, enabling ML. So with these architecture principles, if we look at what are the typical steps of building a data lake, you first start with storage, right? And I think we have established that Amazon S3 is our storage location. But if we just talk about a typical data lake, we're not really talking about cloud. You would of course start with where like, are we going to keep these on solid states or hard drives? How much data we want? Where do we set this up in our data center? Things like that. The second step is, how do we move data into this data lake? So of course, AWS has various tools, both for batch data as well as real-time data. So we bring that data in, and then we have to do some cleansing, prepping the data, cataloging the data. So which means we have to have some knowledge about the data that's coming in. We don't really need to know the structure. We don't really want to wait to understand the structure, which at least some knowledge, like what department is sending this data or what application is writing this data, things like that. And then once we do that, we move to step 4, which is configuring some kind of security and governance policies. So maybe the finance data coming from the finance department should not be visible to all departments. Maybe only the finance department should be able to see that, whereas data coming from our engineering team is it's okay to make it available to all departments. So something like that. So you enforce these policies so that only the authorized personnel are able to access the data that they need or they should need, and then finally make it available for analytics. So these are the typical steps regardless where you build your data lake. And so when we are defining the AWS data lake, so if you see this diagram on the left, we have both a data warehouse and a data lake. And like I said, we are not trying to replace one or the other. We want to make sure that they both can go hand in hand. So if you already have a data warehouse, you don't really need to discard it. You just add a data lake and kind of make use of that data lake. So if you add a data lake and maybe some sources go directly into a data lake and some sources go directly into a data warehouse, and then data gets exchanged between the data warehouse and data lake, maybe that's something that can initially you can start with that, and then eventually maybe you want to route all the sources to go through the data lake first, whatever makes sense for that use case. But the point I'm trying to make here is you don't really need to ditch your data warehouse just because you're moving to a data lake. You can always keep both of them running, or both of them, and the chances are you need both of them, right? So maybe you can use data warehouse for relational data and data lake for non-relational data. It's up to you, scaling out. If you need to, store data not only on S3, but you might want some data within your VPC because it's more secure. You can always scale out your data lake outside of S3 to Amazon EBS, which is, our block storage that comes with EC2. And then, you have a diverse set of analytics and machine learning tools on the top that can make use of this data. As you can see, there's a big rectangle in the middle called the catalog, which is a complete picture of what data you have both in your data lake and in your data warehouse, so that the consumers can now basically go to the catalog and try to understand, oh, okay, the data that I need is available in the data lake, or maybe some of it is available in the data lake and the rest of it is in the data warehouse. So to get that simple idea, you make available some metadata through this catalog. And working on this data without really having to move the data, teams don't have to move the data. They can just come in and bring data from multiple places into their systems and then work on it without having to, do anything within the data lake. Okay, so let's do a deep dive into the components. So S3 is the base. We talked about this. It's highly secure, highly scalable, durable, and you can take any kind of data that you need. So whether it's data coming from websites, mobile apps, corporate applications, sensors, you can ingest that data at any scale. Data can be in any format: unstructured, logs, dumps, JSON files, XML files, CSV, Parquet. And then you can also define lifecycle lifecycle policies, which means data may be initially in one tier where it's a little more expensive than other tiers, but you probably, since it's new data, you probably need that available in that standard tier because a lot more users need that data in a much more real-time fashion. But let's say 6 months from now, the data is not being accessed as frequently, then you might want to move that data into another tier called infrequent access tier, which is less expensive, maybe half the cost, because it's no longer used at the frequency that it used to be used. And then maybe 2 years later, you don't even need it in that infrequent access tier. You can move it to some kind of an archive because users maybe only need it once a year or twice a year. And even then, they don't really need it in real time. They can put in a request and wait for a day or something. That way, you can further reduce these costs, because if you put everything in the standard tier, your bill is going to go high. You're paying for services you don't really need. So that's basically a flexibility that AWS is providing you to make a decision as to which tier, how much data you want to put in, how much, or in which tier. S3 storage, right? Natively supported by big data frameworks. So we want to make sure that our consumers are able to simply come to our location or our data lake and get all the data they need without having to make a lot of modifications. So Spark, Hive, Presto, and many other tools, they are natively capable of handling Amazon S3 without you having to write in extra code or anything. And then you're decoupling storage and compute. We talked about this. S3 is great from that perspective. It has 11 nines durability because of when you write to S3 standard tier, it's always stored in multiple locations. And so if there's any reason one location goes down or you lose that, it's always available in another location within the region. You don't need to pay for data replication within a region. So that part where the data is being copied to multiple places, you're not really paying for that. AWS is taking care of it. You only pay if you replicate or make copies of this data in another AWS region. It's secure, both from the perspective of data at rest as well as data in transit, and it's low cost. Moving data into this data lake, there's multiple ways. So if you're moving data from your data centers, your existing data centers, you can use Direct Connect, which is a dedicated connection between your data center and AWS. Snowball, we talked about it. It's a device that you can order. Snowmobile, it's pretty much the same, except it's much bigger in scale, petabytes. Database migration service, that's a service AWS provides to help you move data from your databases into databases or into S3 in AWS. Storage Gateway is another great service where if you want to leave your applications on-prem for whatever reason, but then use S3 as the storage layer, Storage Gateway can make that happen. And as far as moving data from real-time sources is concerned, we have services like Kinesis and IoT Core that are in real time writing directly to S3. So we have all these mechanisms to bring data into your data lake that AWS provides. Okay. Now, once the data is in that raw zone, we talked about some process that can, modify or transform the data or take multiple sources and put together another data set that's kind of curated and transformed, right? So for that, AWS has a service called AWS Glue. Of course, before Glue, you had to write this or manage all this using services like EMR, or maybe have clusters in your on-prem data centers to run some Spark code to take all these raw sources or the data coming from these raw sources and put together another data set. But with Glue, it's completely serverless, managed by AWS. So you can come in and simply write your code and then provide that code to AWS, and Glue can run that code either on demand or in a periodic basis to move that or to perform ETL on that data. While Glue is really popular for that, there are a couple of other features that AWS Glue provides. One is catalog, a data catalog. So we talked about how important it is to have a catalog for your consumers to come in and understand metadata about the structure and whereabouts of whatever data they need. Now, while it's great to have a data catalog, something needs to understand your data and then write to that data catalog. And you don't want to be heavy lifting that part, because then you will have to write code to go through every section of your data lake and then try to understand that data and then write to the catalog. Instead of you having to manage all that, AWS Glue has a feature called Glue crawlers that can, quickly go through all your data and then understand it and then write to the catalog. You can customize those crawlers using classifiers, to provide some idea to the crawlers. Hey, this is what you can expect in this particular data set. So if you want, maybe you can use these column names or something like that. Job authoring, when it comes to ETL jobs, there are multiple tools within AWS Glue that make it easy for you. So there are auto-generating Python and Scala tools within AWS Glue that can, so you can just simply click and drag and drop, and then it'll automatically write the code, write the template for you, and then you can go in and modify. So at the time this deck was prepared, AWS Glue was the only service, but recently in last reinvent, AWS Glue Data Brew was also announced, which means if you're not familiar with coding in Spark or Scala or Python, you can actually do the exact same thing, but through drag and drops and clicks. So AWS Data Brew basically gives you an interface where you can bring data from different data sets, perform operations by clicking things, dragging, dropping things, and it'll automatically do what you would otherwise do through coding. So it's really cool. You might want to look into that. We talked about glue crawlers. So just digging a little more deeper, they can automatically build your data lake and keep it in sync. So if initially there's one kind of structure, but then the crawler runs a week later and finds out there's a new structure or maybe a new column added, then it can update your data catalog accordingly. And then they can automatically, yeah, like I talked about, how your schema could change. So it can actually always go in and try to extract schema definitions as it discovers new data. So you can detect schema changes and maybe even version the tables. So if there's a new version of schema, then instead of overriding your previous version, it can actually create a new version within the catalog. And it can also detect Hive style partitions. So for example, if you're bringing data in on a daily basis and you don't really want to, keep it all in one place where anytime somebody needs to run a query, it's going to scan the entire data set. Maybe I just need to scan data from May of 2021. So why would I don't really want to scan the entire data set. Instead, if we write it in such a way that the data is partitioned by maybe day or month or year, then if I need data just from May of 2021, I can simply go to the partition that contains data from May of 2021. And you can also nest these partitions, by the way. So you can have partitions by year, and then within that partitions by month, and then within that partitions by day. Built-in classifiers, we talked about it. So popular types like JSON, CSV, and you can also write custom classifiers using grok expressions. And you can run these crawlers ad hoc or on a schedule. And they're completely serverless, and you pay only for when they run. All right, so if we just look at what Glue is doing with our data lake, let's assume for a second that we have three Amazon S3 buckets, one for raw, one for staging, and one for processed. So we talked about these three zones, bronze, silver, and gold. And let's say all the data is coming into that raw stage, right? So you have a Glue crawler that's trying to understand that raw data and then writing to the data catalog on the top. Then you have a Glue job, whether it's done through code or whether it's done through data brew, that transforms that into a staging or into a intermediate staging stage or staging zone. And then you have another crawler that tries to understand that data and writes to the data catalog. And then you have another Glue job that's again written through code or data brew, and then transforms that one final time to a production or processed zone. And you again have a final crawler that understands that final data set, writes everything to the catalog. Now your users or your consumers, based on their expertise level and their authorization, they can basically pick and choose. So if there's users who always want to go to the raw to the process stage, always get it from the gold zone because they don't want to do anything, any kind of heavy lifting or anything. They just want the output or the processed data, which is probably 80% of your company. They can directly go to that process state or processed or the gold zone. But then there might be some data scientists who want to actually go to the middle one because they have some expertise in taking that intermediate data and then doing more things than the gold zone would allow them. Or maybe there's really advanced users who want to always go to the raw stage. Maybe you have some users like that. All of that information is in the catalog, so they can pick and choose where to go to based on their authorization levels, or if they're authorized to do so. So putting all this together, we looked at the previous slide that we looked at is just that part in the middle, the red dotted box. And then we have data on the very left from various sources, whether it's your sensors or mobile applications or databases or on-prem automations, or maybe just archives. So you have all this data coming in, and we have all these tools that help you move the data into your data lake. So Direct Connect, Snowball, Kinesis, IoT Core, Storage Gateway, Database Migration Service, and now we have other tools like Data Sync. So you can use all these tools to move data into your data lake. And then on the very right, you can see the consumers, your analyze section that can go to the data catalog, understand what's in your data lake, and then get what they need and either process it or visualize it or just query it. I'll talk about some of these tools that you see on the right, like Athena, Redshift, EMR, QuickSight. But you get the general idea of how you put your data lake together by using this method. Take a quick pause. Okay, thank you. Okay, so let's talk about Amazon Athena. Amazon Athena is basically an interactive query service that makes it easy for you to query data from Amazon S3 directly using standard SQL. So instead of having to, write Spark code or something to understand the data, you can simply use your SQL capabilities to query data on Amazon S3. So typical users are data scientists and analysts who are used to using SQL, but in the past they've always done that on data warehouses. Now they can do it on data lakes. They can query instantly, zero setup cost because it's completely serverless. You just need to point to the right folder and start querying. Pay per query. So instead of paying for how many instances are running or how many machines are running, they pay by how many times the query is being run and how much data is being queried, things like that. And you can reduce the cost by compressing the data. So if less data is being read, which means if the data is compressed, the less data is being read, and the query charges or the Athena charges will go down as well. Open standards using a ANSI SQL interface, JDBC. So if you have tools that you have on your local that you want to just connect to Athena through JDBC, you can do that as well. And you can even do complex joins and do complex data types as well. So now we looked at how to query the data. What about visualization, right? For that, we have a tool we have a service called Amazon QuickSight, which is a fast cloud-powered business intelligence service. So if you have your management that's looking for dashboards or visualized outputs instead of running queries, you can make these visualizations available to them. You can build them on QuickSight and make these available to them through a very simple tool called QuickSight. So these dashboards, they're all available through the web browser. You can embed them into your applications, things like that. We'll look at that in a second. So no service to manage again. QuickSight is a completely serverless service, which is you just pay by users. So you also pay by what you use. So if you have just dashboards that you're making, then you may want to just choose a reader type of user. Whereas if that user is actually authoring dashboards, then maybe you can just pay for the author type of user. It's scalable and it's fully integrated with other AWS services. So if you have sources not only on S3, but maybe Redshift or maybe Athena or RDS or Aurora, QuickSight can be used for all those sources. Here's an example of a dashboard where you put together what's going to be in that dashboard, you author it and make it available. And users get a link and they click on it and they get to come to this dashboard. You can also embed these dashboards in your application. So if you have maybe a single page application, Angular application, or React application, and you want these dashboards to be on that front page, you can embed it in this style as well. Now, as far as processing this data is concerned, we talked about Glue. But if there are existing processes that you use, like frameworks like Spark or Hive or something else, you might want to spin up a Hadoop cluster. And Amazon EMR is a managed Hadoop cluster platform that, or it's a managed cluster platform that simplifies running big data frameworks. So you can actually not just do Hadoop, but also do Spark and other frameworks. These are suitable for users like data scientists and data engineers who want to process vast amounts of data using open source projects rather than glue. You always will see latest versions of the frameworks. Low cost, Amazon S3, it can use S3 as a storage rather than defining HDFS, and it's really easy. There's about 19 open source projects or more, maybe 19 at the time of this presentation, but maybe now we support a lot more. So Hadoop, Spark, HBase, Presto, and many more. Finally, one of our favorite services, Amazon Redshift. It's a cost-effective data warehouse that can extend your queries to the data lake. So you can, if you have a requirement where part of the data or maybe a section of your data lake, you query it way too often and the queries are huge, and it makes sense to actually move that data into a data warehouse and run these queries on top of that, both from a cost perspective, because if you're running queries on a extremely frequent basis and these are vast queries, you might want to not use Athena at that point, because once the um, once the amount of queries or amount of times you put in a query is going over a particular limit, Athena probably might not be too cost effective. It might make sense to move the data into a data warehouse and just run these queries on the data warehouse, because then you're just paying for your data warehouse on an hourly basis, and you can run as many queries as you want. Another feature or another scenario where you might want to use Redshift is if you have hot data and cold data, and we'll talk about that in a second. Amazon Redshift, fast at scale, open file formats. You can ingest data from multiple formats. It's extremely secure and it's inexpensive. We found out that our customers have found out that moving to Redshift, they are paying 1/10 of the cost of what they used to pay for when they ran a traditional data warehouse. And sometimes in almost in all cases, it performs much better than what they had in their data warehouse. So you're getting better speeds and better performance at just 1/10 of the cost. Another important point about Redshift is it's massively parallel, which means we have parallel cores that are processing the data. The data is always stored in multiple systems in a parallel, or nodes in a parallel fashion. So your queries first go to the leader node, and then the queries get forwarded to these parallel nodes, so that data can be fetched in parallel at any kind of scale. So as your cluster grows, as your data warehouse grows, we add more and more nodes to it. And I talked about how you might want to use Redshift along with your data lake. And that's where Redshift Spectrum comes in. So let's say you have most of your data on your data lake, but then a subset of that data in your data warehouse. And now you're running some query, and then occasionally some queries might not just need the data in your cluster, but also need to bring some data in from the data lake as part of that query. It might make sense to use Amazon Redshift Spectrum, because then you can actually run a query that takes all the data that it has on the cluster itself, and then also goes to S3 and brings some data from there and clubs it all together as if it's all one table. The advantage of this is maybe you have 80 terabytes of data in your data lake, and you probably need only 10 terabytes in your Redshift cluster, because that's what you frequently query. But then occasionally you need to also scan 40 terabytes from your data lake, because sometimes you might want to also get some results from your data lake in addition to what you have in your data warehouse. So if you split your data into hot data, which is data that you query on a much more frequent basis, and warm data or cold data, that's that you don't really query on a very frequent basis, you can leave the cold data on S3, keep the hot data on Redshift or on your data warehouse, and use Redshift Spectrum to query it all together. So here's an example. So all your data is on the data lake in the very bottom, and it's all cataloged in AWS Glue. Then you use some copy commands to copy hot data to your Redshift cluster. And then you query the data directly on the data lake by using Redshift Spectrum. So you have users on the top using some tools to make some queries. And whenever hot data is enough, it'll just return the results from the hot data. But then if your query needs to go outside of the hot data and go to S3 to bring part of the results from there, it can go to Redshift. It can go to S3 through Redshift Spectrum, bring the data back and put it all together, give it all together to the front end, to the user. And by the way, these Redshift Spectrum nodes, they can scale out as well. So if your query initially might need only a few or only a few gigs from the data lake, then maybe it'll only start with one. But if your query is big, where it needs to get terabytes or maybe scan terabytes of data, then it can scale out in a serverless fashion. Now, what about machine learning? So we have tools such as SageMaker, DeepLens, so SageMaker Recognition, Comprehend, Translate, all these tools. And they all as well can go to data lake and get the data and run what they need, or maybe write to the data lake. So the point we're trying to make on this slide is your data lake is not necessarily only for analytics, but you can also use it for machine learning. Okay. Okay, so we so far looked at how to put together a data lake and what are the different services you can use with that data lake. But what about security? So if you were building this data lake on S3, there are mainly two services that you're looking at, right? When it comes to storage, one is S3 itself, where all the data is and where you keep your data, and then AWS Glue, where you keep your metadata. So by default, all Amazon S3 buckets are private. So you come in and you basically have to write S3 bucket policies or IAM user policies to configure who can access what data, and then what data is secured, encrypted using Amazon or AWS KMS. And then maybe part of the data needs to be tagged so that, if the data contains some kind of personally identifiable information or PHI, you might want to put in some compliance controls on that as well based on the tag. So you have to manage all that within S3, but then also separately do all that within your AWS Glue catalog for the metadata, because we don't want unauthorized users to even look at the metadata, right? Because sometimes when they look at the metadata, they might actually be able to make sense of your original data as well. So it's very important to do this security control or this access control in both your actual data lake as well as your metadata catalog. Unfortunately, since these are two separate services and Amazon S3 doesn't really know whether you're storing the data lake data or what kind of data it is, it's not going to control things across services, right? So you'll have to do this separately in two separate places, which means you are now the owner of managing to make sure that these are not out of sync. So this is one big problem if you are trying to build the data lake and manage it by yourself within AWS. And we'll talk about a solution for that as well. So building data lakes can still take months, even though we have many managed services. It can still take months because you have to figure out what are the sources, and then create these S3 locations for various types of data, maybe in multiple regions, and then configure access policies in your buckets, and then also map these tables to, or map data catalog tables to S3 locations, and then write ETL jobs to load and clean data. Even if it's a simple load and simple clean, maybe you're removing some unwanted data, or maybe you're removing duplicates. Even those simple tasks, you will have to write the code to manage it. And then you have to also create access policies for your metadata, which is in your AWS Glue catalog. And then, of course, configure access manually for the consumers. So figure out which consumers need to be able to access what, and then manage all that in both S3 as well as Glue catalog. And then you rinse and repeat. So you do this in a rotated fashion on a periodic basis to make sure that your data lake is always intact and secure and compliant. This is a manual process that can be completely error prone and time consuming. And that's really where AWS listened to our customers and launched a new service, or relatively new service, called AWS Lake Formation. This service was announced in reInvent 2018, and I think it went live in the middle of 2019. It's a completely managed serverless service that can do all this heavy lifting for you while you focus on your use case or on your company needs as far as the data lake is concerned. So moving the data, storing the data, cataloging it, and cleaning the data. So if there's duplicate data, or if there's unwanted data, or there's a lot of unnecessary metadata that comes with your data. So cleaning all that using machine learning technologies, AWS Lake Formation can do that for you. And then enforcing these security policies across multiple services. We talked about how you need to do it separately, once for S3 and once for Glue. AWS Lake Formation just manages all that for you. So you can come to AWS Lake Formation and simply say, I want this finance data set to only be accessible by users from the finance department. Nobody else can access it. And then AWS Lake Formation will automatically make sure that behind the scenes, both the S3 data as well as the metadata in AWS Glue catalog is only accessible by the finance department based on their IAM credentials. But it's all managed for you without you having to go in and manually manage in each service. And then, of course, it can provide insights as to who's accessing the data and what kind of data is being accessed, things like that. So how it works, you start by creating a data lake, and then start by registering existing buckets, or importing or creating a new set of buckets, and then registering those buckets as your data lake, or parts of your data lake. And then, of course, importing data. Then the second thing you do is set up permissions at the table level or at the user level. And then you start adding metadata. So metadata is a great way to increase collaboration and usage, because you do want your users to have metadata about your data. They shouldn't have to go in and look at all the data by themselves to figure out what data it is or what kind of columns they have. So they can still simply come to this data catalog and get information about it. And then finally monitoring and auditing what's happening within your data lake. So all this is managed for you by AWS Lake Formation. And behind the scenes, AWS Lake Formation is using all the services that we talked about earlier in the session. So it's using Glue Data Catalog, It's using glue jobs, glue crawlers, any existing connections, databases, tables. It's using all that. But on top of all that, it's adding blueprints and workflows. It's a feature that makes lake formation capable of doing what it does, and then adds another layer to access the or to manage the access permissions, and then of course the monitoring. Right, so we talked about how we get started. You either register existing buckets or create new buckets, and then basically say, yes, these are all part of my data lake. And from that point on, AWS Lake Formation will manage those buckets for you. The moment you register a bucket as a lake formation managed bucket, then automatically from that point on, AWS Lake Formation will take care of the access. So even if you went in and previously provided access to that bucket, then if anybody who's trying to run queries on that bucket, if those permissions are not set up in lake formation, like it'll actually deny it, because those services or those buckets are now registered under lake formation as part of your data lake. Easily loading your data lake or data, basically. So you define a blueprint that says where my data is going to come from and how frequently. So either an existing database that's on RDS, or maybe logs that are coming from my load balancer or from CloudTrail or from Firehose. You basically define all that in a blueprint, and then lake formation automatically starts moving that data into your data lake. And what are you doing in your blueprints? You basically are saying, what is the source and where do I need this source to, with this data to go, and how often? And once you define that on the right, everything else is taken care of by lake formation. So discovering the source tables, converting the formats, partitioning the schemas, and then keeping track. So all of this is managed for you by lake formation. And of course, you can also go in and customize aspects of it. Deduplication. So if you have data coming from multiple sources, and then maybe 30% of both these data sets are same, you don't really want to store both of them in your data lake. You're unnecessarily paying for storage you don't really need. So AWS Lake Formation can detect these duplicates and dedupe that data for you using ML transforms. Here's an example. We already have within Amazon algorithms or tools that we already have developed using ML. And here's an example where we have Prime Video, and we also have IMDb. Both of them, they have their own ID. Like for that particular movie, maybe the ID in Prime is ABC, and the ID in IMDb is 123. How do we know exactly that these two things are the same movie? It's by using machine learning to go through the content, to go through the description, and trying to understand, oh, it's the same actors, same synopsis, same maybe the release year, same exact name, but maybe there's multiple movies with the same name. So using all this information, machine learning or the ML transform is able to give it a score and say there's a 90% match between these two movies. So based on that, it's able to find out that they both are the same movie, right? So the same exact technology that has been built by our Amazon core team is also being used by Lake Formation to figure out what data is duplicate data. Here's another example. We have Amazon on the left selling shoes, and then we have Zappos, which Amazon acquired, which is also selling shoes. And maybe they're both the same product, right? So to figure out which products are the same, what are the duplicate products, the same ML transform can be used. Okay, so we talked about how access definitions or access control is defined in today's world. You first go to S3 and define all that in S3, and then you go to Glue and define all that in Glue. which becomes extremely tedious. You are now going in and managing two different services and making sure they're all in sync, which can become very error prone as your data scales or as your data lake scales. And the other problem is none of these services, especially S3, you can actually control at a column or row level. It's based on files. So you can basically say a user can have access to this file. Now, if that file has 100 columns and that user is only supposed to access 60 of those columns and the remaining 40 that user is not supposed to look at, you can really do that in current world. But lake formation enables all that. So you come in to lake formation. Once the buckets are registered under lake formation, you come in and basically set access control based on the catalog itself. So you come in and say, for this meta table in the catalog, this user or this group of users is only allowed to access 60% of the columns. You set all that in lake formation. And from that point on, lake formation manages all for you, make sure that the access control is managed for you both in S3 as well as Glue. So if there's a service, right, like coming from the right, if there's a user using Athena to query, and that user is only supposed to see 60% of the columns, that's all they're going to see. Okay. So here's another example where you can control permissions. You can come in and grant permissions on tables and columns rather than buckets and objects. So when you set up these permissions within lake formation, you're not really talking like S3. You're not really talking about objects or files or buckets. You're talking about tables and rows and columns. So once all that is set up, here's another example where you're basically saying user 1 should have 60%, whereas user 2 can have the entire 100% of the or 100% of all the columns. From that point on, if you actually look at the intricacies of how exactly lake formation works, a query comes in from a user, and that query goes to Athena, right? Athena understands that it needs to get some get that data from S3, but it also knows that it needs to first go to the data catalog. But that is with AWS Lake Formation. So it sends a request to Lake Formation. Lake Formation then says, oh, looks like this user is authorized to look at this data, but only part of the data. So I'm actually going to give you some short-term credentials, right? And then these the services that are actually querying the data will use those credentials to go to S3 and get the data they need or get the data that they're authorized to see. And then that data is presented back to the user. And these users can be IAM users, IAM roles, Active Directory users, VF Federation. All of these can be managed by AWS Lake Formation. Searching and collaborating across multiple users. So you have your data in your data lake that's queried by Amazon Athena, and you can filter based on like you can put in some text and filter all that information, and also collaborate between users by saying, okay, this data is owned by so and so, and then maybe also set some kind of sensitivity level to say this table has some PHI, or maybe this column has PHI, so that any consumer that's querying that data, now you can actually set security based on the PHI, right? So you can do all this using this collaboration within lake formation. So it makes it much more easier. I would highly recommend that if you're starting with the data lake now, you should look into AWS Lake Formation. Auditing and monitoring in real time. So these logs can show you which permissions have been granted, which permissions have been revoked, who accessed the data, what was requested for, and what kind of data was returned. So you can download all this information from CloudTrail And of course, you can analyze the data using the same exact tools as well. Okay. Finally, I just want to show you the various services that fall under databases and analytics. So you have in the very bottom our data movement services. We talked about DMS, Snowball, and Kinesis. And then the one section up is the data lake. So S3, Amazon Glacier, Lake Formation, AWS Glue, all these technologies. And then one step up is our tools. So databases, Aurora, RDS, Neptune, DynamoDB. And then under analytics, we have Redshift, EMR, Athena, all these that can work hand in hand with the data lake. And then blockchain, of course, manage blockchain and templates. And then on the very top, we have our BI and machine learning tools. So QuickSight, SageMaker, Comprehend, Recognition, all these tools to work hand in hand with the data lake. Okay. So I know we have we're about 1 hour, 20 minutes in. That was all I had as far as the data lake is concerned. I'm available if you have any questions at this point. But thank you so much for your time.
Hey, thank you, Aditya. So I can call you Adi. Hey, Adi. So thanks for the session. So we have a couple of questions in the charts. Maybe I'll be displaying on the screen here.
Okay.
So let me go one by one from here.
How to automate data lake with multiple accounts in AWS. So when you say automate, what is that? Like, are you talking about how do we build it, or? So, I mean, just let me try to take a shot at that. So if you're using AWS Lake Formation, you can definitely bring in buckets from multiple accounts and have your Lake Formation setups manage all that, even though the buckets are in multiple accounts. If you're not using AWS Lake Formation, then it's just like any other AWS environment, where if you have multiple buckets in multiple accounts, you have to define cross reference roles or cross account roles and manage all that by yourself. Of course, to automate that, you can write scripts. You can write IAM policies that are managing all that, or you can even do CloudFormation stacks that are deployed into multiple accounts, things like that. I'm hoping that that answered your question. Please let me know if it doesn't. Okay. So I'm looking at other questions. So elaborating on scaling out data using Amazon EBS. So we talked about how we use Amazon S3 as our main base, right, for our data lake. But it's possible that you have a scenario where your data cannot leave a VPC. By that, what I mean is, as you know, Amazon S3 doesn't live within a VPC. So maybe you have some compliance rules that say the data has to be within a virtual private cloud, which is your private perimeter within the cloud, right? So maybe that data is on an EC2 instance, which uses Amazon EBS. EBS is our block storage service, where the volume of data or volumes of data are attached to virtual machines, and you store the data on the EBS volumes themselves. And those volumes are always on a VPC or within a VPC. So if you have a requirement like that, where maybe 90% of the data can live on S3, but then 10% of data cannot leave your VPC, you can scale out your data lake outside of S3 into Amazon EBS and putting it all together, right? That's really what I meant by scaling out EBS. What are the alternative methods to perform ETLs or ELT other than Glue and the traditional approach. So other than glue, the extremely popular alternative is using EMR. So uh, if you have awareness with or expertise with open source frameworks such as um, Presto or Hive or HBase or any other tools like that can run within EMR or Spark, for example. If you, I mean, Glue is also Spark, but maybe you want to use traditional Spark, not the Spark that comes with Glue. You can definitely use those methods to transform the data. You don't have to use Glue all the time, right? Maybe you have a complicated scenario, or maybe you have existing scripts that you already wrote that you can bring into Glue, right? So you can do that. How do we handle data source from multiple regions as some of the data client? So that is, again, you need a multi-region data lake, which means within your lake formation environment, you basically, or if you're using lake formation, you basically say, I have all these buckets, and the data within that bucket needs to stay, or within a particular bucket needs to stay in that region. So you make sure that the data it never leaves that bucket or never leaves that region. And if you have a Glue meta or Glue data catalog for that region, or if you have, let's say, I mean, 3 buckets or 3 regions, and 2 buckets are in one region or 2 regions, and then you have a sensitive bucket that needs to stay in that region, then you might want to have a dedicated Glue data catalog for that region alone, so that neither the actual data nor the metadata leaves that region. Can you elaborate on scaling out? Oh, I think I just answered that question.
Yes, yes, yes. I think
Um,
you have answered the questions. So
yeah. If you have any follow-up questions, let me know. I can stay here for another few more minutes.
okay, hey guys, you can ask your questions, whatever you have. You can post whatever the questions you have. Adi is here to help you.
Not that I'm aware of. I'm not aware of Glue supporting Snowflake unless that has been recently added. It can write and read to S3, and from that point you can always import it into Snowflake, because as data can be imported into Snowflake or exported out of Snowflake into S3. Talking a little bit more about EMR, happy to. So EMR stands for Elastic Map Reduce. So actually, let me put back my presentation. Okay. All right. So Amazon EMR stands for Elastic Map Reduce. So when Amazon EMR was created, Hadoop was really popular, but MapReduce was the most popular thing that was happening at that point. So I think the Amazon service was named after MapReduce. However, EMR doesn't mean it only can do MapReduce. It can do any kind of big data processing. You can bring in Hadoop or Spark or any kind of framework. So it's basically analytics and ML at scale. What happens is within EMR, you define a cluster, and each cluster has a master node, and then child nodes, and then task nodes, or core nodes, and then task nodes. So all these nodes are basically EC2 instances, and it's all managed as one environment for you. So if you need to install a framework, you just basically go to EMR and say, for my cluster, I want Spark and Presto and maybe Pig. And all these frameworks are automatically installed for you. Now, when you need to run a particular script, like maybe a Spark script. You submit that to the master node, and the master node submits that to the core node. And the core nodes can be responsible for multiple things. They can actually further delegate those tasks to task nodes if you have them, or else do the processing by themselves. Now, as far as data is concerned, behind the scenes, you can have HDFS Hadoop data file system within your cluster itself. But the problem is, the scaling, right? You're unnecessarily paying for storage, or unnecessarily paying for compute when all you're doing is storage. So again, to make that part easy, EMR has something called EMR FS, where your data is actually on S3, but then to your Hadoop cluster or to your EMR cluster, it'll look as if it's on HDFS. And so you're basically attaching S3 to your EMR cluster and calling it EMRFS, but it looks like HDFS, but it's actually EMRFS that's behind the scenes connecting to S3. So that's really how EMR works. It's pretty low cost. And the other advantage is, if you have some nodes or if you have some tasks that need to run in the middle of the night, doesn't really have to, be done by the morning, or maybe doesn't really have to provide some on-demand response to users. You can use spot instances and say, I have these tasks. As soon as the spot instances become available, or they come under the price I want, go ahead and spin those up and run these tasks. And then as soon as you're done, get rid of those spot instances. And then so all this can be managed by your master node and core nodes together. Hopefully that answers your question.
Yeah, I think yes. Thanks. We have okay, we have a question, so which is more interesting.
Hands-on session. Yeah, so I am happy to help with that. But we will need to nail down on the topic. If we can do one hands-on session with all the topics I touched, so you'll have
Yeah,
to pick which session you want or which service you want to dive deep on, and I'm happy to do a 2-hour session or something. So you have to understand, I'm in the West Coast, so every time we need a session, I'll have to wake up at 5 in the morning. So maybe we can set something up where we are doing it a little later in your day or something like that, and I'm happy to help.
right, right. That's really great. Thank you very much, Adi. We really appreciate you because of the time. This is only
Mm-hmm.
one concern you and we have. So, and this is, it's early morning to you, and you are agreed to have the session with us. Really appreciable. Thank you very much, and looking forward to host you another session in the future.
All right, my pleasure. Hope that
Thank
helped.
you very much. Thank you, guys. Have a nice day, everyone. Have a good day. Bye bye.